Hello everyone. In this video of our chapter triangles, we are doing some criteria by which we can say two triangles are congruent. Okay, so in the previous video, I have explained actually what the congruence is. So before covering this video, try to cover the previous one so that all the terms we will use there will be clear to you. Now there are some criteria for convergence of the triangle. So it's written there two triangles are congruent if they satisfy any of this rule. Okay, the first one is SSS, which means side criteria. So if all three sides of one triangle are equal to three sides of another triangle, then the two triangles are congruent, which means suppose this is one of the triangle and it's PQR, and we have one more triangle. And suppose this triangle is ABC, then we say the both triangles are congruent only when our side PQ, which means PQ is equal to AB, this one PQ is equal to AB, PR is equal to AC, and QR is equal to BC. So we can say they are congruent by this criteria, and this criteria is known as SSS, which is side criteria. Okay, but there is we already discussed that when two triangles are congruent, we can write triangle PQR is congruent to triangle ABC. Okay, but there is a one condition in which we can write this specifically. If I write triangle PQR is congruent to triangle ACB, then we know two triangles are congruent, but this notation is wrong. Okay, we have to write the corresponding part. Suppose P is written there, then PQ is equal to AC, but PQ is equal to here AB. That thing PQ is equal to AB, so we cannot write like that. We have to follow the same steps like that. P, then Q, then R, then again to P, which is PQR is congruent to ABC. Okay, this is known as corresponding parts. Now the next criteria is given there, side angle side. So if two sides and the included angle of one triangle are equal, which means suppose one triangle is there, and this one is the another triangle, and suppose this triangle is ABC and this one is PQR. So we can say the side angle side criteria, if any two sides like AB is equal to PQ and BC is equal to QR, if these two are equal and the included angle of the another triangle, which means included angle there, that between the two equal sides, this angle, okay, and this angle, if they are equal, then we can say the congruency of the triangle holds, and it's due to side angle side criteria. So then the triangles are congruent, it's written there. So where AB is equal to PQ and BC is equal to QR, and this included angle is also equal. So we can say triangle ABC is congruent to triangle PQR. Now the third one, it's written there, angle side angle criteria, this one. So if two angles and the included side of one triangle are equal to corresponding parts of another triangle, then the triangles are congruent. which means, so let me draw two triangles again. It is the first one. Suppose this triangle is A, B, and C, and this one is P, Q, R. So it's written there, example, angle A is equal to angle P, which means angle A is equal to angle P. And after that, angle B is equal to angle Q. Angle B is equal to angle Q. And AB is equal to PQ, which means this side AB is equal to PQ. So we can observe that this angle are equal and that sides are equal, and again these two angles are equal. So it follow the pattern of angle, side, and again angle. So we can say triangle ABC is congruent to triangle PQR by the criteria of angle, side, angle. Okay, that's the way we can do. Now the fourth one, it's angle side criteria. So if two angles and a non-included side of one triangle are equal to the corresponding parts of another triangle, then the triangles are congruent. So what is written there, I am explaining this one. This one is the triangle. Okay, and this one is another triangle which is congruent. So suppose its name is A, B, C, and it's P, Q, and R. So example, angle A is equal to angle P. Like this angle is equal to this. Angle C is equal to angle R, which means angle C is equal to angle R. Now AC is equal to PR. AC is equal to PR. So it's okay. Now in this one, we cannot do like that. It's written there, we have to take the uh, one of the triangle are equal to corresponding parts, okay, and a non-included side. So we have to take this side like ABPQ, or we can take BC or RQ. Okay, so in that way we can say they are congruent by criteria angle side. And we can also take there its angle, and side, angle, and side. So now in such case we can say triangle ABC is congruent to triangle PQR by the criteria of angle side. Okay, so that's the fourth one. Now the last, we have, suppose we have two right angle triangle, then it's for that case. Okay, and its name is right angle hypotenuse side. So let me draw two right angle triangle. Suppose the first one is A and it's B, it's C, now it's P, Q, R, such that angle B is equal to 90 degree, angle Q is also 90 degree. So in such case, we can use the criteria if the hypotenuse and one side of one right angle triangle are equal, which means hypotenuse is AB there. And in this triangle, PR is our hypotenuse. So if two hypotenuse are equal, which means AC is equal to PR, one side of one right angle triangle are equal. Okay, so after including hypotenuse any one pair, which means maybe AB is equal to PQ, or we can take the base BC is equal to QR. If that thing hold and any one of this hold, then we can say two triangles are congruent using the criteria of RHS, which is right angle hypotenuse side. Now we can say triangle ABC is congruent to triangle PQR by RHS, and I am following you how we can say it's right angle R, hypotenuse H, and any one side this and this S. Okay, so its criteria is RHS. Now it's written there after. Okay, now up to now we are done with all the criteria by which we can prove the two triangles are congruent. Now there is some more things are there. So it's the key idea. Once we prove triangles are congruent, we can apply CPCT. Okay, so what is CPCT? We will understand. Its full form is corresponding parts of congruent triangles. So their CPCT, congruence part of congruence triangle, means if two triangles are congruent, then their corresponding sides are equal and their corresponding angles are also equal. Suppose this is one of triangles and this is also another triangle. It's given that the triangle ABC is congruent to triangle PQR. So if we have to use CPCT, then for congruent triangle, the corresponding sides are equal, which means AB is equal to PQ. So we can write by CPCT, AB is equal to PQ and AC is equal to PR, and the third side BC is equal to QR. And that's for side, same hold for angle also, which means angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. Okay, but the main thing you have to keep in mind in CPCT, if it is written that ABC is congruent to PQR, which is there, then we can take only AB is equal to PQ. Suppose if you are taking AB there and you are making it equal to like AB is there, okay, and ABC is congruent to PQR. So you only write AB is equal to PQ. If you write AB is equal to PR, then it's wrong. Okay. So you have to think this in mind. Okay. And in the word itself, it's written that corresponding parts. So it's necessary. Now it's the explanation I have already given there. So it's written. So once congruence is proved using any criteria, which is side angle side angle RHS, and one more we have done is angle side. Okay, so if triangle is congruent, we can use CPCT to conclude equality of the remaining parts. Okay, so it's all for the congruence and like CPCT. Now I have some question. It's some statement and we have to do some proof. So if two isosceles triangles have equal vertex angles, so let me draw the given triangle one by one. Okay, these are the two isosceles triangles have two vertex angles. So suppose this is A, B, C, and this one is P, Q, R, and one corresponding equal the base. Then triangles are congruent. We have to prove. So in isosceles triangles, two sides are equal. So AB is equal to AC, and their PQ is equal to QR. Now it's given that have equal vertex angles, like angle this one is equal to this angle and one corresponding side equal, which means this side is equal to this side. So we have to prove that two triangles are congruent. Okay, so first of all, we have to check that the given information is drawn correctly or not. Okay, so the equal vertices there, A and P, the angles are equal, and one corresponding side, which means BC and QR. Okay, then triangles are congruent. So now we will start our proof. Angle A is equal to angle P and BC is equal to QR. Okay, it's there. Okay, now if we say let angle A is equal to angle P and suppose it's of X measure. Okay, it's X. Now for isosceles triangle, we have some property that angles opposite to equal sides are also equal. Okay, now if we find angle B, so using property of isosceles triangle, we can say angle B is equal to angle C, or interior angles of triangle have some 180. So angle B plus angle C plus angle A is equal to 180. B is equal to C, so we can write angle B plus angle B plus X is equal to 180, or 2 times of angle B is equal to 180 minus X, or we can say angle B is equal to 180 minus X by 2. Okay, 180 minus X by 2. And if we perform same thing, you can try. We also get angle Q is equal to 180 minus X by 2. So now we can say after that angle B is equal to angle Q. Okay, which means now the criteria is angle, this one, and again angle, and then side. So we can say angle ABC or triangle ABC is congruent to triangle PQR using the criteria angle, angle, side. Okay, that's the way you can do proof of such type of questions. So it's all for our video. Keep practicing of all these things, and if you found any doubt, then you can ask me through my Urban Pro profile.